all that work that we did with differentials is going to help us in finding derivatives of more complicated functions. For instance, when I have y is equal to the tangent of x cubed minus 4x squared, I see that I have this function inside of that other tangent function. So I'm going to use a process called U-Substitution. And what I'm going to do is let u be that interior function, that x cubed minus 4x squared. Then the differential of u is going to be 3x squared minus 8x. And each of those are in terms of x, so I can just factor out the dx all the way. This is going to be very helpful in helping us find the derivative of our tangent function. So how we're going to do that is go back to our function, and instead of looking at this as a tangent function in terms of x, we're going to look at it as being a tangent in terms of u, and it's just tangent of u. Instead of taking derivatives right away, what we'll do is take differentials. So dy is going to equal the differential of tangent of u, which is secant squared u du. Next, I'm going to take all of those functions that I have written as u and du. I'm going to take their values of terms of x and substitute them back in these two places. So what that's going to mean is that right now we have dy is equal to the secant squared of u. But I see that u is this x cubed minus 4x squared. So that's what I'll put inside of here, x cubed minus 4x squared. And du is going to be 3x squared minus 8x dx. Looking at this function's differential first allows us to kind of use an algebra trick in order to find the derivative, because I can divide both sides by the same amount, and that's a legit algebra trick. I'm going to divide both sides, however, by dx, making the dx cancel on the right side. On the left side, obviously, we have dy dx, which is Leibniz notation for the derivative. So what I'm left with is the derivative. That's secant squared times the 3x squared minus 8. I'm also going to pull that 3x squared minus 8x out in front of the secant. It's kind of a normal thing to do so that we don't get fooled into thinking we're taking the secant of a product. We're just taking the secant of x cubed minus 4x squared. And that value is getting multiplied by the 3x squared minus 8x. But what we're left with here, this is the derivative.